Well, welcome. Hey, on behalf of Open Source Six Sigma, we welcome you to this Lean Six Sigma Black Belt training course. My name is Dave Dupree, and I'm going to be your facilitator through the various sections we're going to cover here in the course. I've got close to 4 decades of experience as a Master Black Belt and was fortunate enough to be part of Six Sigma as it became Six Sigma at Motorola, and then through to going outside of Motorola to other companies, and then companies like yourself, where we're going to try to deploy the Lean Six Sigma methodology. Right, so the course has been designed to build your knowledge, capabilities, competencies, so that you can help improve the performance of processes. And then subsequently, right, as your processes improve, the performance at the business improves as well. So whether you call it top down or bottom up, making every process better will make the business performance that much better as well. The course is process centric, and you'll see that as we go. We always talk about process improvement and data driven decisions. So you'll look at how we improve processes using the Lean Six Sigma methodology with a little process and project management and change managements thrown in as well. So by taking the course, we think that you'll have a very well-rounded and firm grasp on the tools and methodology. And right, I'm hoping that through my experience and some of the examples that we show you here, that it'll be very effective in your learning and ability to apply this in your business. In this section, Understanding Six Sigma, we're going to cover the body of knowledge elements listed here. Just what does this term Six Sigma mean? A little bit of history on Six Sigma, continuous improvement in general. Some deliverables of a Lean Six Sigma project. The problem-solving strategy. How do we develop this whole idea of Y is a function of X? And then who are we trying to satisfy, right? The voice of the customer, our business needs, and also employee needs as we look to improve our processes. What is this sigma, the sigma in Six Sigma? Well, we start with the basic premise, which is the standard deviation, right? The Greek letter sigma, which represents the standard deviation. That's what most people are familiar with, that we represent the mean, the standard deviation represented by this Greek letter sigma. In the Six Sigma methodology, variation, right, is the enemy. We want to be predictable in our output. And so the bigger the standard deviation of the process, the less predictable we are. And in the graphic we see here, the red distribution represents a process with a wide variation, more likely to be a customer dissatisfier, where the distribution in the blue is much narrower, much more predictable, right? We would say that that would be a better customer satisfier. And so as we progress through looking at the different tools, we'll look to see, how do we keep our process both on target and with as little variation as possible. So it's all about being able to predict what the outcome is going to be so that we know that we're going to satisfy our customer with their particular expectations. So the standard deviation calculated, we show the formula here. Some would say it's sort of the average deviation of each data point from the mean. So we take all the data points, subtract the mean, right, square that quantity. We divide it by the sample size n, and then we take the square root of the whole equation. And that just puts it in the same units as the mean. So standard deviation, if our mean is in feet, the standard deviation is going to be in feet. If our mean is in PSI, our standard deviation is going to be in PSI. So that's how we calculate it. And again, the smaller, the less the deviations from the mean, the more predictable and the better we are at meeting our customer expectations. You'll also see on the normal curve, the standard deviation, right? The first standard deviation is that first point of inflection on the normal curve. So we talk about how many standard deviation units are under that curve, and that's what we're going to look at on the next slide. So here we see sigma as sort of a measuring unit on a ruler. So we talk about how many standard deviations as we go out from the mean represent the area under the normal curve. And so if you remember way back to statistics class, if you ever took one, we talked about going to a normal curve table and looking at the area under the curve for certain distances, sometimes we call those z values, from the mean. So in the standard curve, some of the common terms we talk about, plus or minus one standard deviation, we've got 68% of the data. That's where the bulk of the data is. Plus or minus 2, we talk about 95% confidence intervals. All that means is that we're within 2 standard deviations of that average. Plus or minus 3, which we use for control charts, 99.7% of the curve, all the way out to 6, which has virtually all of the area under the curve. The curve does go to plus or minus infinity, and there's still a little teeny bit of area way out there. But when we talk about 6 sigma, we usually are looking at this view where we get out to sort of 2 parts per billion under the curve. And what we want is, since our process is going to have this output, again, the smaller the standard deviation, the better. And we can actually predict with the normal curve how much product is going to be in each of these sections. You know, plus 1, plus 2, plus 3 standard deviations away from the mean. So another view of what we talked about the area under the curve. Now we use the sigma level as our measuring stick to talk about how many standard deviations fit between the mean and our nearest specification level. So in a true Six Sigma process, we have 6 standard deviations all the way back between the specification limit, right, what our customer will accept, this case on the upper end. So that would be a 6 sigma process that we're showing here. If we could only fit 5, it would be a 5 sigma process. 3, a 3 sigma process, right, all the way down to, if we could only fit 1 and our specification limit was over here, we would have a 1 sigma process. So this is what we talk about when we say the sigma level. In some companies, like when I was at Motorola, we measured our process. One of the ways we would measure it would be on this sigma scale. How many sigmas to the good is your process? Again, with the goal of having 6. So just another way we use this idea of sigma or standard deviation or the Greek letter in order to describe our process. Here we have some other metrics that we might use to describe our process. And I always say use the one that is easiest to communicate within your organization. So at Motorola, we use Sigma level because, hey, we were a Six Sigma company. Everybody talked about Sigmas and how many Sigmas their process was. But a lot of people can't relate to the fact that they're on a Z scale and, you know, 1 is 68% and 2 is 95%. That doesn't translate right in their vernacular. So a lot of times we'll use things like yield or parts per million. We can use defects per unit, yield. So whatever works for your organization. And the good news is we can convert back and forth between these different units. And we'll get into some detail about when each one is appropriate and how to do the different calculations. And luckily, Sigma Excel will help us to do a lot of the hard work. We don't have to go look up things in tables and use a lot of calculators, etc. So we'll take a look at all of these different units in a way to measure the goodness of our process, or look the other way, the glass half empty. What is the defect rate delivered to our customer? Here we put it all together for you. We've got the yield, we've got our sigma quality level here from 1 all the way up to 6. Yield can translate into parts per million defective, and then we add in a little cost of poor quality metric. So our sales point for companies is that we typically start in the 2 to 3 sigma range, and I can't tell you the number of times when I do my measure phase for a project, I calculate all of my metrics here, and we start out in the 2 to 3 sigma quality range, which means, hey, our yields are 80 to 90%, right about 68,000 parts per million defective. And the sales point for, why do we want to do improvement projects? Why do we want to be a continuous improvement, a Kaizen type of company? Well, we want to get rid of this cost of poor quality. And later in the presentation, we're going to show you the cost of poor quality iceberg and all the things that are down in there. But you can see that if we move from sort of 2 or 3 sigma up to this 5 or 6 sigma range, we're talking about 20-25% cost of sales, turning that from just getting the product out, right? So scrap and rework and wait times and inventory or lack thereof of inventory turns, and turning that into cash. So, right, you can imagine, right, the advantage is a company that has less than, right, a 10% sort of waste in their process built in to a company that's got 20 to 30%, and what an advantage that would be out in the marketplace. So the whole idea is that as we move up this sigma scale, as we get our yields up, as we get our defects down, there's going to be a cost savings, a cost benefit to doing that. And so that's what's been sort of the bellwether, the benchmark of employing Six Sigma methodologies is, hey, let's go get the cost of waste out of the process and turn that into profit. So what is the Six Sigma methodology, or probably better said, what is DMAIC? Define, measure, analyze, improve, and control. So it's a simple 5-step process, sort of program management, project management 101. These are milestones. We have 5 of them. And there are certain tasks and tools that are used within each one that we will cover as we go through the course. So it wasn't, any magic. You could call this PDCA, which, right, some companies do. Some people use different acronyms here. But it's very simple that I'm going to do about 20% of the work to get to each one of these milestones. And we've nicely apportioned some activities that should take place in order to get from the beginning to the end. So what we do caution is where everyone tries to jump to is just to go implement improvements. There is some discipline in the process to say that, well, before you can really do that, we need to know where we're starting. We need to know that we've gotten to the root cause. And then when we make the improvements, they will actually stick and make that waste and variation go away. So very simple 5-step process, toll gates, milestones, call them whatever you'd like. You can rename it to be whatever you like, but this is stuck over close to 40 years now, and I always say, right, it works every time. So uh, that's what the DMAIC means, and we will cover each one of these phases in details as we go through the course. The toolbox that helps support the whole Six Sigma DMAIC methodology is quite broad. There are quite a few tools. You won't use every tool on every project, but it also has a broad set of problems that we can go after. And so when we look down sort of at a y as a function of x down here for, right, what does the customer perceive as its value? When we look at dividing that into cost, quality, delivery, or speed, right, it's a function of things like earnings, the product design, so we can work on things to make our products better. We can look at making our yields better. We can go faster. We can look at maintenance type items where our production lines are available to make product. And then also the people side of it, right? What are all the folks that have to operate together, right, as a system in order to support our products and processes. So it's a broad tool set, as we say here. Hey, the tools aren't necessarily designed just for the Six Sigma methodology, but we've organized them into places where they are probably most applied on that framework of the DMAIC process. And to give you an example, when I was in my early years at Motorola, we taught courses at Motorola University on all kinds of tools. Here, go take one on two sample t-tests, and here's one on Pareto charts, and right here's another one on process mapping, and they were interesting, and I tried to apply them as I could, within my job. But where we really had the breakthrough, where we really finally figured out this whole idea of Six Sigma and DMAIC was apply it to a real world problem. Go through those 5 steps. Pull out the tools that you need as you go through those 5 steps. And it was just a night and day difference. So the tools by themselves, hey, they're great. I use a lot of them in one-off situations. But when you apply them to a real business problem, right, going through the DMAIC methodology, that's where we really get the most leverage from the tools as a whole. Oh, this is a classic slide. Reminds me of my early days in Six Sigma at Motorola. The fruit tree. Uh, hey, the good news is if you're just starting out and you haven't really applied much problem solving in your processes and in your business, there's a lot of low hanging fruit. I can use from very simple tools and get myself from a 1 to a 2 to a 3 Sigma process, right? We can use very basic tools, Pareto charts. We can use process mapping. We can use check sheets and things of that nature, just to standardize how we do the work and to make it better. And then there's some nice things we can do up here when we've got to 3 Sigma, moving up a couple notches on the scale. We use usually a little bit more sophisticated tools. We really have to understand the input to output transfer function. But when it makes sense, right, we try to climb even a little bit higher. And then sort of the nirvana is when you get to the point where I can actually design the process, design the product to be defect free from the beginning. So we talk about right, design for Six Sigma, that this new process line isn't going to make defects, and I'm going to always be able to satisfy my customer. So that's always our aim. Sometimes it's not very hard to achieve. Sometimes it can be quite a challenge, especially when we're looking at technology limits and things in order to make some of our products and some of our processes. All right, so a few quotes from our sponsors or some of the early adopters of Six Sigma. General Electric, I did a little bit of work there, but mostly I was involved in Honeywell, which was then Allied Signal. And you can see, right, it's not a slogan or cliche, right? It's a disciplined process, but again, not very difficult. 5 steps, 5 tollgates, 5 milestones, and right, it's part of the DNA how we do work. So Jack Welch was a big proponent, and he was kind of the one that came up with the idea, right? Variation is the enemy, although that goes back to Duran and Deming and those, but he really took that to heart and said, if my process has a lot of variation, then I know my customers not going to be happy. Honeywell was one of the first companies outside of Motorola to go after it. Larry Bossidy and his crew, and they really figured out that they could apply it to outside of just the manufacturing floor. They could do it in finance. Right, GE actually did it in their financial arm, and right, Lockheed Martin, Navistar, some others. Right, the savings in just the first few projects just sold them on the whole concept. So right as this whole idea of Six Sigma went outside the doors of Motorola, right, the first companies that went to try it and applied it, right, really found it to be groundbreaking and fundamental to how they were going to use continuous improvement to improve their businesses going forward. This slide shows a little bit of the history, which I was privileged to be a part of most of it. It says here Bob Galvin really kind of laid out the ideas of Six Sigma, and it's interesting. It was really spurred, right, for those that are old enough to remember, was the loss of the Quasar TV business, right? The works in a drawer. And I used to always joke when I'd first go out on the consulting stuff, right? Our TVs are so bad, right? We put all the defective components in this little drawer, so when the technician comes out to fix your TV, he can at least do it quickly. And so, right, if you think, right, Motorola, transistor radios, right, the next level up would be televisions and, right, any other communication equipment that went with that. So that was really a blow. So, right, I was part of this whole idea of, okay, quickly we're going to make a 10x improvement in our quality levels, and we called it the Quality System Review, which turned into the Malcolm Baldrige Quality Award. So, right, we kind of chewed off a couple things with our initiative, and right, we came up with the whole concept of right Six Sigma and why we needed 6 of them. The whole idea of rolled throughput yield came in here in the early 90s. Bill Smith, right, is the sort of the father of Six Sigma. My old boss, Mike Harry, worked with him in Chicago, right, coming up with some of the concepts and writing the first papers on the subject. Mike left Motorola in 1984. Right, Texas Instruments down there at the Defense DSEG, and some of the guys at ABB were working on right some of the pole-mounted transformers. Right, they furthered it. Right, they were the first ones to kind of test it outside of Motorola. And then the call came. I was one of these right application experts that left to bring the whole idea of DMAIC and Six Sigma to other companies. So I started at Allied Signal. It was real cool. We got Larry Bossidy, right, the CEO of the company, to say, hey, this is what we're going to do. We're going to use this as our leverage to quality, as Galvin did at Motorola. And it was a lot of fun in the early days. If you went to work at a company to install Six Sigma, their stock usually went up. So I made a teeny bit of money with Allied Signal, Navistar, GE, right, and but it was also during the dot-com days, so right, stocks were generally going up. Jack Welch, right, they were the biggest company in the early days to undertake Six Sigma. Matter of fact, it was so big, even though right some of my peers helped do the consulting, we really met with their quality training group, and as quickly as possible, we transferred over the whole idea of training to be the black belt, right? This training that we're going through here, so that they could deploy it worldwide as quickly as possible. So, right, the few experts that were around in the early days would have been stretched too far to really go to every division within General Electric worldwide in order to make it go. And then the industries that we've been in since, personally, I've worked in automotive industry, the government industries. I've worked for the Department of the Army, TSA, FAA. We've worked in insurance, banking, so you name it. The beauty of the DMAIC process is that if you have a process and you can write down the steps, we can figure out how to make it more efficient, take out some of that cost of poor quality. But in the early days, this is truly what really happened. Started at Motorola, did a little bit of work at ABB and Texas Instruments. Allied Signal was the first company to really try it outside of Motorola. GE then kind of took it to the next level, and then I would get phone calls. Hey, I need me some of these belts and some of this continuous improvement work. Right? How do I make that? How do I make that happen? So a little bit more about what's a sigma and why do I need six of them? Well, it really is just math. So we figured out that for complex products and processes where you've got a lot of things strung together, that if I could move each individual one up towards that Six Sigma level, when I add them all together, I'm still going to get a very good process yield. Or the idea of if I only produce 3.4 defects right at any one step, if I add them together, I'm still really in this low parts per million as delivered to my customer. And then there's a lot of other good things that go with that, right? If I'm really at 3.4 defects as an output, well, do I try to find those? Uh, right? If I have to take a look and see, right, what will the impact of the customer be um, versus, right, could I even realistically find things at that level or that low level of defective? And this all allows for the mean to shift back and forth a little bit. We'll get more into that as we look at calculations of sigma, Six Sigma, and rolled yield. Uh, but the whole idea of the six standard deviations helps us to withstand process variation. And if we can truly get to that level, that we will be very predictable to our customer. And we can do it for very complex products. Like I worked in the defense industry, we had maybe 10,000 parts in a unit. So think of aerospace, airplanes, automobiles, down to some of our simpler products like a pager that only had 26 parts. And so you could really look across your production facilities, and if I could get each process up to this level, good things were going to happen both for the less complex to the most complex products we had in our portfolio. A few other historical tidbits. If you read some of the early works that came out of Motorola, we only had a four-step process, and we truly did just steal plan, do, check, act, and called it measure, analyze, improve, and control instead. There was a little bit of a method to our madness. So you saw a few slides ago when Bob Galvin asked for a 10x and then a 100x improvement in quality. What we actually did, rather than just start firing off projects, is we actually did the measure phase for almost, well, we did for every production process. So if there was we manufactured something, whether that was a circuit board, whether that was a pager, a telephone, we went and figured out what the Sigma quality level was for every one of those processes. So in the 80s up to about the beginning of the 90s, we really executed a whole bunch of measure phases, and then we said, well, the things that we're going to improve are going to be the ones that are the lowest on the Sigma quality scale. So we really started here, and then we did analyze, improve, and control on those low-hanging fruit yield processes, those ones that were lowest on the scale, in order to improve those first, and then go up and up and up until we were able to push everything towards that Six Sigma level. When we went into taking this on the road, and at GE, it was most obvious because they tried to go so far so fast. Well, we needed to get more into project selection. So what projects should we go after? Because they didn't go and do all this measurement early in the game. So we did add that step. They added the step. We then adopted that as now a 5-step process. And the whole reason was, hey, we need to do enough definition of the projects at the beginning to decide which ones we're going to go to work on. So we're going to have this portfolio of potential projects, and then we're going to go launch those through the rest of DMAIC based on the ones that we think have the most return on investment. And thus then the other toll gates, the other milestones here help to make sure we launch the right one. So if we get to the measure phase and we find out that it's not really the return that we expected, we go back and we pull another one out, and we bring that one forward. But yes, it did start out as just a 4-step process, but the reason was we just really did a process inventory in the early days of Motorola and got things through the measure phase. So now, as applied more broadly to other companies, we do this process definition stage in order to do a good job at project selection, so that the ones that we bring forward have the most likelihood to succeed and have a good return on investment for the efforts. So let's put a few tools out here on the DMAIC process, and we'll look at a few different process flows like this as we go, to make sure that we ground you kind of where we are in the DMAIC process as we go through each one of the 5 phases. So when we look at, hey, what are we trying to do within each of the 20% milestones here in Define, it's all about, hey, what project are we going to do? What does it look like? Let's write it down in some way. We need some resources, so we're going to form a team, and then we're going to test it with an initial guess at what would the value be to the customer and to the business. So if we're going to put some effort into it, what does the return on that effort look like? And hey, then we're 20% done. Then we move into measure. We make sure that the metrics that we're going to use are valid. So we're going to talk about how are they measured and how accurate is that measurement. And the ultimate is, hey, what is the current capability, right? Where are we on that sigma scale or yield or parts per million defective? So what is the real quantitative way to look at the problem? And then we start to look at this idea of y is a function of x. So in the beginning, it's just, well, what x's could it be? And we're going to quantify what are the particular outputs that we're going to try to improve. So, a process could have dozens of outputs, and what we're really going to look at is the one primary and a few secondaries that we're going to try to improve. Next, we look at root cause analysis. So those x's and y's that we hypothesize here in the beginning are not all important. And what we find is we could come up with dozens of potentials in our list of x's that impact our y. And eventually, as we get down through the process, we find out it's sort of 1, 2, or 3 that are really important, which is a good thing when we get to control. So in analyze, we really torture the data. We think there might be an x and y relationship. Okay, well, let's prove it or disprove it. So we'll look at graphs and charts and finish off with some statistical hypothesis tests. Does x really drive y? All right, then we move into improve when we can, and we like to then take the relationships that we think are there and actually test them in real life. So as we change the x's, the inputs, can we see the y actually move? And we do that through regression or designed experiments. All right, once we understand our y is a function of x relationship, we move into, hey, now can we use that information to come up with solutions? We start talking about implementation plans for how we're going to make the process better. And then probably the most important phase, but the one probably with the least statistical tools is, well, now how are we going to keep it there? And so if we figured out how to make the process better, how are we going to control it? So let's validate that we did get better. We're going to talk about a control plan and a reaction plan in order to keep the process at the new, better level. And then finally, validate that, hey, the cost of poor quality savings we thought were actually achieved. And I don't know, I find many times we do better than we thought in the first place. But even if we get 50% of the way or 75% of the way there, we did get some savings, and then we can move on to the next project. Here we take the define phase to break out some of the activities that we will go through in order to get our project started, and we'll talk in some details here. But first, at a high level, what is the reason we want to write a project? Well, basically, let's call that a business case. What's the business reason to go out to fix something? So maybe our customers aren't happy. Maybe it costs too much to do a particular activity. Maybe we're throwing away too much product. So we're going to start off with a business reason to go forward. We're going to assign some resources. So one of the resources will be someone like you who's taking this black belt class, because you are the competency holder. We're going to teach you tools and techniques. We're teaching you the DMAIC process. So you will be the keeper of the process, and you will help lead the team through sort of the statistical or data journey to get from beginning to the end. You'll also have some team members, some subject matter experts. So we don't expect any one person to have all of the answers, but to gather a group of subject matter experts that know the process, right, know the customers, know the business itself, in order to get from the beginning to the end. We talk about stakeholders in the general sense of they're the interested parties in having something made better. So they might be process owners, they might be managers or plant directors, but somebody that's interested in this business case being made better. We then write a charter, so sort of the formal, what does the project look like, who's going to work on it, what is the timeline, and we'll talk about the specifics of that here coming up. We scope it, so what's in, what's out, and that's a very important step in order to define success, because if we try to bite off too much in a short period of time, right, we might not be successful. So I can tell you a number of times where if you start small and get there fast, it's a lot better than trying to do it across the world for all processes to satisfy all stakeholders everywhere. Right? Sometimes you might still accomplish it, but it will take a lot longer than if we can make it into some bite-sized steps. We start off with another way to do scope is, well, what the heck is the process that we're gonna work on? So if I look at what I call the left boundary and the right boundary, where does the process start? Where does the process stop? And that's the portion of the process that I'm going to try to improve. We estimate the savings. Hey, so what is the reason for the business case? Is it taking too many hours? Is there too much overtime? Is there too much scrap? Is the customer satisfaction not at the right level, or some combination thereof? But there will be a savings of sorts that we will estimate. When we get to that point, we've developed our charter and estimated sort of the return. Right, we're going to have a decision point. Is that the one that we're going to go forward with? If yes, right, we get the resources approved. We get the business lead and/or the process owner to commit the resources and commit to the timeline, and then we're off and running. And really, at that point, we're into the measure phase. So, right, this idea of the define phase, is not really that difficult. It's good to do a thorough job to make sure we scope things correctly. But that's all there is to it. If we can define what we're going to work on and who's going to work on it, we're ready for the next step. We do put the decision point in here that if we don't like the answer, right, we're not going to get enough cost. We can't really figure out what the scope is. We can't really assemble the resources. Hey, there's plenty of things to work on, right? So we show, hey, let's just start over. Let's go pull another idea out of the hopper and bring that one forward. So I've been working on a continuous improvement for almost 40 years now. I'm still doing it, so there's never a lack of processes and projects that we can go to try to work on. We'll talk about this towards the end of each phase, right? We'll have a set of deliverables. We'll talk about a Tailgate review. So some of the things that are in the define phase, some activities or some actual documents or data outputs that we might produce are listed here. Right, we need to know, right, who is going to be our team. What are we going to measure? What measurement are we going to improve? That's what we call the primary metric. I talked about a high-level process map. What portion of the process, or what process are we working on? And so we want to be able to at least show that in a couple blocks. What do we need to be careful of, right? So as we improve one thing, we don't want to make another thing worse. So we're not trying to sort of squeeze the balloon and move the bubble back and forth to different departments or to different sections. We'll talk about some lean tools. So can we lean out the process, right? Make the workflow better. Who are the stakeholders, and right, what is their involvement in how the process or project moves forward? A little project plan. Hey, we made it simple. 5 toll gates, 5 milestones. When do you want to get them done? And we can move very fast if we have the resources to do that, right? Or we can go along as the resources are available in order to execute through the whole DMAIC process. And then we constantly look out for roadblocks, and we're going to talk about roles and responsibilities of different players to make sure that we continue to move forward, that we can overcome any of the roadblocks that we might run into. And again, that's why we involve stakeholders. That's why we ask for resources before we start, so that we can minimize the number of issues and barriers that we might have going forward, like time to do the project, like access to the process, etc. So when we look at the whole Six Sigma strategy, the DMAIC process, you've probably heard me say 100 times already, process, and there really is an emphasis on fixing the way the work is done, the way that business is conducted in order to make the output better. So we can't just go move the outcomes without knowing how the outcomes were produced. And again, it's a wide range of things that we can look at. So we can look at metrics that might be on a month-end dashboard. If we don't like the numbers, well, let's go try to improve them. We can look at things like how long does it take to do an approval? Who should be involved in the approval? Do we meet our plan or not? So we can look at some gap analysis of if we've made financial plans, do we usually march in the right direction? Can be applied to people processes like recruiting and hiring, and we actually call our process to in all the personnel moves, we call it the hire to retire process, and all the little pieces that happen along the way, and we have process owners for that. So it can apply broadly in all areas of the business, and we call it a breakthrough strategy because it can handle all those different types of business processes, and we include a wide range of tools. And when we look at how do we measure success, it can be in lots of different output metrics. So it can be purely financial. It can be hours saved. I've done a lot of projects on voice of the employee. So is it fun to do this process? Do I feel like when I come to work this month that I've been empowered and able to do my job in an efficient manner? So if we really look at cost of poor quality in a broad sense, and again, we'll have our little iceberg coming up here in a minute. Hey, there's a lot of things that aspects that we see kind of above the waterline, things that are easy to measure. But then there's also sort of these lost opportunities that go along with the things that we can actually see and measure. So we're going to use this as our engine to take processes, measure them, make them better, step and repeat. So we'll continue to use this simple DMAIC process to attack business issues, and then as we make them better, we go on to the next one, and you'll see sort of this repeating engine that once it gets rolling, it's a pretty fun thing to continue to make things better. So going back in time some, uh, one of the things right in a conventional, right, 1-2 sigma process was just simply, hey, I'm going to produce things as long as they are within my customer limits, right? They go to the ship table, and then I probably have some really neat little processes that take the bad ones and finesse them to go into the good side. And then what we typically say is we got some sort of a yield, probably in the 90%. So with whatever I started with, if I started with 100 input units and I got 90 right output units, right, I had a 90% yield. I patted myself on the back, and right, this stuff just went to the scrap heap, the garbage pile. Maybe I could recycle some of it, but that's really the way we looked at how to get things to market, how to get things to our customer. And what we're going to say is, well, we really need to look a little bit stronger at, well, how much of this can we do the first time? And can I get rid of the finesse uh, extra processes that move the stuff just into the conformance area? And we'll even look at, hey, the closer I can get on target, perhaps maybe my customer is even more satisfied as I shrink the variability in my output. So we're kind of going to try to move away from, hey, I can get it in the spec somehow, some way, through miraculous acts of people, to being very predictable that I don't have to do these types of things. And actually, I produce very little in the bad pile outside of my spec limits. The DMAIC problem solving strategy does revolve around a very simple, right, mathematical concept that I have an output that I'm going to try to improve, and its level, its variation is driven by something. And right, we're going to say that it's driven by the inputs, process variables, the way in which the process is conducted. Our job through the DMAIC process is to find out, well, which ones of those are important. So in the old days when I was looking at making things better, right, our Y would go bonkers, whatever that is, right, it would go out into left field, and we'd say, oh, we need to do a process improvement activity. And so we would simply, everybody together in a room, we'd write down on the board, and we'd say, we need to fix all of these things. And sometimes it would be 5 things, sometimes it would be 12 things, sometimes it would be 20 things. And so we'd come up with an improvement plan, and we'd go try to fix all those things. And usually for a short period of time, the Y would get a little bit better. But we had no idea, what the function was. Were those X's important? We just said, hey, we think they're important. Let's go fix them. And then sure enough, the Y would change again, go in the wrong direction. We would scratch our heads and say, huh, well, we already fixed these 12 things. Now what? So we might try it again and right, and then fail again. So the idea of the DMAIC process is to really get to the heart of, we have an output. There are some inputs we probably don't know exactly what they are at this point, that really impacts their performance. And so our job through the process is, number one, put the big list together and then whittle that list down as we go through to make um, our understanding of the process and the function of what inputs drive the output and by how much. So it's really that simple or that complicated, however you'd like to look at it, but you'll hear us say y is a function of x over and over and over again. And the whole idea is that through DMAIC, through the problem solving strategy, we can come up with those few inputs that are really important that drive our output. Here's a simple example that might help us with even project scoping, because we may not even want to look at these things right as a whole. Sometimes we might, if that's what it takes to make it happen. But I'm going to focus on the bottom one here. I've worked in our global business solutions department here for the past 6 or 8 years, and very familiar with the end of the month closing process. One of my favorites. Well, the length of time that it takes in order to do that closing. Right, we're going to start off with well, how far off are we? Right, we're going to do a little trial balance. Right, we're going to do some corrections. We're going to look at all the sub accounts and right, do they flow up to the top? Some of my favorites, we call them journal entries, right, or credit memos. So, right, how do we move money to different places and account for the fact that something hasn't arrived or been paid for yet? And then finally, right, are there errors that find their way into the trial balance and so on and so forth? And after a number of days of crunching and crunching, right, we fix these inputs, and that takes a certain right number of days in order to perform that. So if we're going to try to fix the right time to close, we're going to have to focus on some of these right lower level inputs to make them better. Which one? Well, we probably could figure out where should we start. Right? Is it data entry errors? Do we have too many sub accounts? Not enough sub accounts? Right? How far off is our trial balance when we go to close? At the end of the month. But by breaking it up into these pieces, we can see that right, this time is a function of all the steps that are right underneath it, and you can go several levels. So we could look at the way that we roll up the sub accounts, and we could have a sub process to that where we have y of the sub account time is a function of these things, and you can continue that down for several levels, and we'll take a look at that when we get into process mapping and scoping of our project. But very simply, if we look at some output that we want to improve, we can start to quickly think about, well, hey, what are the things that could impact this time? And we have some process knowledge that would tell us, well, gosh, we never really close on our first trial balance, right? And gosh, we write a lot of these credit memos, and I know we're always sending some files back to get data entry things checked or fixed, and so this is where we start. And through the process, we're going to say, well, which ones of these are the most important? And then we might break these down further to write even further subsets. So we get sort of a hierarchy of X's and the X's that we need to improve our output. Thinking of that idea of y as a function of x, here's a simple exercise to do in your head here as we go through the slides. So pause the video here after I explain this. So you're going to have a tailgate party. I don't know if it's for a football game, a soccer match, a baseball game, and right, how would you define right, success? How would you know you did a good job in planning a successful event? So what are the factors that you would need to consider in order to have, right, a successful party? So just take a few minutes and write down or might remember in your head, but write down a few things. Or right, what are the X's that you would consider in order to have a good tailgate party? So you can pause now, and then I'll give you some of my ideas. So what did you think of? Well, who are you going to invite, right? So there's going to be an invite list. Where is the location? So is there a spot that is already designated where people can park, or is it some lot where it's sort of first come first served, and you're need to going to go there early to stake out a space? What kind of food are you going to have? Do you need a grill? Do you need to pick up some sub sandwiches? What kind of right drinks are you going to have? And right what kind of ice, and am I going to meet the needs of everybody there? Do I have some water? Do I have some vegetables if people are right vegetarian on the food side? Do I need chairs and tables? Are you going to really do it up and have a generator and a TV and watch some of the pregame festivities before you go there? So you can see the list can be pretty long, and right, which of those things is probably the most important to have a successful party? So I can come up with a checklist. Right, the nice thing is I could assign this to different people that are going to come to the party. Right, you bring these drinks, you bring this food. Hey, you get there early. Hey, can you bring your tables? Hey, everybody bring some those foldable uh, chairs so that we have a place to sit, right, garbage bags to right clean up afterwards. So just something even as simple as right a tailgate party or a birthday party or right would have this idea of y is a function of x, right? In order to be successful, right, these are the elements that need to happen in order to see that success. Continuing on with the idea of y is a function of x, and sometimes we call this the Deming funnel. You'll see this in the analyze phase slides. Hey, there's a lot of x's, right? I've done some brainstorming on some processes where we've come up with 20, 25 inputs. Matter of fact, somebody asked me the other day to look at it, designing an experiment for them, and we went through the process, and I think we found 37 different input variables. Well, it's too many, right? I can't control all of those. So through the process, we are going to funnel down through different tools uh, to find out, hey, does this X8, whatever it is, have a relationship with my output? How about X9, right? How about X10? What we'll find in the end is there's really just a couple that we can really demonstrate have this mathematical relationship. This y is a function of x, and we can leverage that, right, as we're showing over here. Well, if I only have two things to control, wow, that's a lot simpler to think about devising solutions, uh, moving into the control phase to put controls on those. If I've only got a few things, right, versus trying to do it for everything. So we call this the trivial many inputs versus the vital few. So you might hear us talk about that. But this is the beauty of the process. And in my almost 4 decades now of doing this, it's amazing how this works out. There's only one, two, or three variables that I really need to pay attention to out of the whole gamut that impact a particular output. Slide shows our ultimate goal. When we get to the end, we should be able to uh, show that we were able to take a process from some not so good level down to a new level, and so we can move the average back onto target and look at the variability. Right, we've got a lot of variability here, and look at how nice and tight the variability is after we've made our improvements. So this is the ultimate slide I like to show at the end of the project that, hey, here's where we were. Uh, Not really good. We had a lot of variation in the process. Customers not very happy. Right, if these are defects, right, that we're throwing away, uh, then we've got a lot of cost of poor quality. And then through understanding what X's are important, we're able to shift the process in the good direction, get better performance, and also better consistency. So we will be able to show graphically, numerically, through the DMAIC strategy that we were able to make this improvement. So this is sort of my capping slide at the end of every project is, can I show how I've made an improvement from where I was to where I will be into the future. Our project that we select to go take through the breakthrough strategy can come from a number of places or some combination thereof. And we'd like to show this as a little bit of a Venn diagram. So the primary reason could be that we're trying to make the customer happier. The primary reason could be because the process costs too much, or the business isn't happy with it, or the process could start with, hey, this is a very difficult process for employees to execute. And I've done projects right from all of the different facets, but there's also usually a lot of overlap. So you can imagine that if a customer is unhappy and we're losing sales, right, that can impact the business. So we have some overlap area here. From the employee perspective, hey, if we hear our customers aren't happy, this would happen in my factory all the time. Or hey, the employees take that personally. Why is it that my output is not right, making that customer satisfied? What can I do differently to make that happen? So we will be looking at these voices and what's the primary, and you're right. How does it sort of overlap in some cases? Uh, Ultimately, right, everything's about the customer who pays the money that makes the business run. But projects may start down here lower, where we're looking at a particular business reason that we need to do some project work. I really have some fun with some of these, hey, employee satisfaction ones that typically go over to the business and also to the customer. I'll give you some examples of some of those. So we'll go into more detail, but a lot of times we talk about VOC, VOB, VOE. Well, that stands for voice of the customer, voice of the business, and voice of the employee. And this is back in the where we're looking at the business case to start a project. Uh, it probably came from some of these voices being loud and not very happy that we're going to try to rectify. There's a people side to deploying the Six Sigma methodology and strategy. And right, it's got a sort of network of experts that you're becoming a part of, right? We're going through the black belt material here. And then there are some support structures with executives and champions over here on the right. And we'll talk about some of the roles and responsibilities of each. So we do have a competency scale that we take different belts through, and we have different levels of achievement. Down at the yellow belt level, right, these would be folks in that do the process right, every day. We might train them how to do a control chart, do a simple map, uh, keep track of some certain metrics, use some very simple tools like check sheets so that they can be good team members and they can be right an extension of the overall improvement effort. Right, then we move up to right green belts who right have the ability to work a simple DMAIC project, usually within their work area. Black belt is sort of the more jack of all trades, where you can work cross-functional projects, projects that are either in your area or out of your area. And then we have sort of a mentoring network that sometimes this can be consultants in the beginning, or you might hire somebody with a lot of experience to help right at all three levels, wherever we're doing more sophisticated analytics and analysis. So let's take a look at right how this all kind of works together and what the roles and responsibilities of each one of the group. So typically a deployment or decision to make continuous improvement part of the business fabric starts somewhere close to the top. You saw in the history, right, it was driven by Bob Galvin at Motorola, right, CEO, driven at Jack Welch at General Electric, Larry Bossidy at Allied Signal. So many times in my consulting role, right, we would go meet with the executive leadership team, right? They're going to make the initial decision that, hey, we want to go forward, we want to do something to make our business better. At the top level, they're looking for, hey, I want to be able to, right, see business improvements. You know, bottom line gets better, my customers are happier. Right, they're going to do the proper level of promotion through the business. Those are simple things. Maybe they make a video. Hey, we're gonna do these things. They post it on your intranet site. What I really liked is it was not unlike Jack Welch to make it to some Tailgate reviews for some of the projects. At Bechtel Corporation, Riley Bechtel would come. We would have a quarterly sort of science fair of projects, and he would walk around and talk to the teams that did some different improvement efforts, so he could get a feel for what some of the efforts were doing throughout the business. So they kind of play a sort of a cheerleader role, but also at the top level, hey, they expect right to get some results that right make the business better for their shareholders. At the execution level, we typically are talking about a mid-level to higher level manager, director, executive director, manager that is either a process owner and they want to make their processes better, or they look at their right yearly objectives and say, hey, in order to get there, I'm going to have to do one of these breakthrough projects in order to meet my goals. So they're going to help to select projects. They're going to help assign resources. So they are usually the owners of those resources, you being one of them. So they're going to put those resources together. We do like for them to participate at those different milestones: define, measure, analyze, improve, and control, which is good in two ways. One, they understand that the execution is going as expected, but it also gives the team and you as the project lead and right an interaction to make sure that you're getting the support that you need. So as things shift and drift, right, you can talk through, right, do I need different resources? Do I need additional data? Do I need support from an outside organization? And right, that's what we look to be. The champion's role is to make sure that the project execution continues in a positive fashion. So there's some time commitment, just like there's a time commitment from the team and the you as the project lead or the belt, um, hey, they need to do these project reviews. They need to help put the charters together. They have to help launch the team. So, right, some fraction of their week, usually not a big one, but some hours per week would probably need to be spent on the effort, and they will need to balance their schedule and put time in order to make that happen. So we always say, from your perspective, make sure you have a cadence to meet with your process owner and your champion, so that you're never uh, delayed by the fact that you can't get on their calendar or don't have time to talk to them. Hopefully, it doesn't have to be as formal a process, but we say, hey, start off with a cadence with some formal check-in points in order to make sure that that's not what slows you down. All right. So then through the belt hierarchy. So masters, that's what I call myself. A long time master black belt, highest level of competency. Really, it's a black belt with some project portfolio experience. When we develop them, we're talking 5 or 6 projects that they've led or they've mentored. Obviously, the more projects you work, the more experience, the more pitfalls you've seen, and they're going to work to get the deployment started. I don't know how it will be at your particular company, but these can be hired from the outside. Sometimes, I did consulting for 20 years where I came in as the temporary master for that company, developed the black belts, developed the masters of the future, and then faded away, and the new masters continued to lead that. Masters can do large projects. In my role now, I do cross business projects when we can't figure out who owns what, and we want to make improvements. So I might span purchasing and quality and engineering in order to look at a particular project that requires all three to play nice together to move things forward. Many times these are the trainers, right? That's right. I'm conducting some training here. Have a portfolio of black and green belts. Always showed you kind of the hierarchy. We'll look at that again, but usually as a master, you'll have a number of black and green belts, at least dotted line, reporting to you. When I worked at Verizon, that was my job. Is I had all of the black and green belts in the sales and marketing organization, and I was responsible to make all of their projects move forward. Make sure they were trained, and we executed on those projects together with the business representative who was a director. There's always a change management portion to it. So, getting the right folks together to make the change happen is always important. We'll talk about some more of that as we go on. There's always a people side to change, and then kind of establish that DNA. So, as we do DMAIC and DMAIC and DMAIC and DMAIC, it becomes part of the culture. And it's fun now. I've been in my current role for about 8 years, and you get a call now, and someone says, "Man, we're really having a problem. I think we need to do a DMAIC project on that." And I always kind of smile, hey, people realize that using this 5-step process can help them to get to where they need to be. All right, the next level down, or maybe the highest level in your organization, a black belt, designated to be a leader, at least in the beginning stages, maybe coach and mentor some green belt projects in the future. You are the keeper of the process, right? So we'll say that a few times. We want to define, and then measure, and then analyze, and then improve, and then control. And so some of the work is to say, hey, we have a methodology to get there. We don't want to just go in and change things and tamper with the process. So you may be called to do things within your current functional role, and may be called to do some things with adjacent functions, again, upstream, downstream, to improve processes. All right, contribute to the right organizational goals. So every year we're going to look at the compilation of projects, the compilation of savings in order to move the entire organization forward. So you probably will have some slice of that responsibility, but it's kind of nice how things roll up and uh, how the return on investment side of DMAIC really speaks for itself. So I'll give a little story that the Department of the Army that I was working at the time decided that, oh, we don't need to do this, DMAIC stuff anymore. And so, right, my whole group was gonna go away. And so we did get a meeting with the sponsor, who was a 3-star general. We walked in with our project portfolio, which had, I don't know, 10,000 projects and I don't know, it was 15-20 billion dollars worth of savings. And we said, sir, before you pull the plug, we'd like to at least show you, the work that we've done and how much we bring to the organization every year. And we said, kind of puff our own chests out, but what other organization can come to you and tell you, right, this is what they saved for you in the past years? And he kind of looked at it and said, okay, keep going, keep doing what you're doing, right? Because, right, there's nobody that can really talk to, hey, we had this many people work this many projects, and right here are the savings that we delivered. All right, and then you become the technical expert on the tools, right, that are inside DMAIC. So if somebody needs to do a Pareto chart, right, you're going to help them, right, put that together. If they need to do a 2-sample t-test, you're going to say, hey, here's the data we need. You're going to put it into Sigma Excel and help interpret the results. So that's kind of a fun role that I still enjoy to this day is, hey, give me the data. I'll help you to interpret what it says. So some organizations have masters and black and green and yellow belts. So if you decide to deploy green belts, uh, they can do projects mostly in their business area. We don't train them in every single statistical tool to the level we're going to go through here in this class. But you can get a lot of leverage if you're doing right 10 small projects in a different business unit that report up through you, right? There's a lot of leverage to getting those 10 projects done, even if they're small ones, in order to add up to a total. So they usually work projects in their existing functional area. Right, they usually are project leads. They will work with you in order to right, achieve their toll gates and to move through the DMAIC process. And right, they learn as they go. So right, green belts will become future black belts and move up the chain. Some companies will have formal yellow belt training. Typically, this is for the team members, the subject matter experts that are going to support projects. So get everybody in the know. What is it that we want to? They know the basic DMAIC structure, that we're going to use a data-driven approach to fixing things, and how they can support those efforts. So sometimes we call them the 7 basic tools, but right, they would know how to put a process flow diagram together of their work area. They might be able to do a little fishbone diagram, maybe construct some Pareto charts, but they become a really good subject matter expert for any improvement team that you're trying to put together, since they know the basics and what it is that we're trying to accomplish through an improvement project. And again, just like for green belts, hey, if they decide that this is an interesting thing, they're really interested in data and data-driven decisions, right? They may be next candidates for a green belt class or a future black belt class. So here we show, the typical support network. Sometimes it's formal where it's direct line. Most of the time it would be more dotted line. You would know as a black belt, right, who your support structure up in the organization is, and then as you become good at your craft, you might have some green belts or yellow belts that you work with all of the time. And the idea here is the leverage that you can get. So, right, as a master, right, I might have 10 black belts that I'm helping mentor, train, right, bring up to my level. Right, each black belt might have 10 green belts that are in their portfolio. So, you have 10 to 1, 10 to 1. It's not unusual for me to have 100 to 200 projects that I have my hand in some fashion in order to do Tailgate reviews to help either the black or the green belts execute those when necessary, and even do a few projects right on my own that are more cross-functional across business units. But the idea is, how far, how fast, how deep into the organization can we get? And it's also nice that if you use this type of structure, at least at the green belt level and probably at the black belt level too, you can develop local right centers of excellence. So it can be at a specific geographical location, it could be at a specific building, a specific department, so that there's always somebody close by that we can go to for help in executing a project. All right. So, hey, what can you expect? Right, you're going to go through this training. You're going to become a black belt. I don't know. Maybe I sometimes like call this the scare slide. But hey, I've made a career of it. I love it. So, I hope that you love it to an extent too. Uh, but hey, you are going to be a team leader, and you're going to have to use some project management skills. You're going to have to use some change agent skills. You got to get your team moving in a direction. You got to communicate with leadership. You got to schedule meetings and get activities done. So I found it a great learning experience, especially in the beginning. I didn't have necessarily all of those skills, but after your third or fourth project, you get pretty good at it. Right, it gives you a chance to do technical reporting to your peer group and above. Right, it's not unusual for you to have to get up in front of some of the leadership team to show some results. Uh, we do give you a support structure, so you have some other black belts and masters that you can go to, and those networks are really important. So you'll see that right as you have other folks that that are going through this program, maybe have a weekly call or a monthly call and compare notes and right, call each other up on the phone, because some of you will get better at one tool than another tool, and hey, leverage that network. And the real right feeling of success is when you achieve that objective. Uh, so it's really a little bit of chaos in the beginning when you're looking at, well, I got to do my define phase, and I got to do my measure phase, and now I got to find my root causes. But if you follow the process, right, more than 9 times out of 10, you will get to the finish line, and you'll be able to demonstrate that you made an improvement to that process, and that's always a great feeling in the end. And right? Then you just keep building on that success. So we're going to give you the training you need to be successful. Right, we will talk about your different roles as a change agent as you go through. But remember, right, you're going to have to do some of the blocking and tackling, setting up meetings and getting your team together and doing some communication up and down the chain to move your project forward. Rules vary a little bit by organization, but this is quite a typical template. There's typically a certification process where you'll get, a certificate of achievement. Might be internal from your company, or there are external certification agencies. But basically, go through the course, complete all the exercises, and then where the rubber really hits the road is doing some projects. And again, we found this at Motorola. There was, I don't know if we lucked into it or what it was, but as soon as we started to take all of these various tools and apply it to a real business problem, it stuck. And so that's where the real learning happens, is to do it in a real process. So typically, a couple projects in your portfolio get you to that black belt level. And then really from the business perspective, what does the business get out of it? They get the business results, and you get the feeling of you help to contribute to that. So the coursework plus a couple projects usually gets you to the black belt certification level, and there are some variants on how that might be applied in each organization. Well, again, in order to be successful, this is what we talk to your leadership. We need certain organizational behaviors to be in place. We need leadership to support the improvements. Walk the talk. Go to Tailgates. Look for the compilation of projects and how it's moving the business in the right direction. Do encourage and award people for completing projects. Are you going to give certain rewards for exhibiting the behaviors? It can be anything as simple as we used to give away little badges for how many projects you completed, to financial rewards for achieving certain milestones within the program. We look for managers to eliminate the functional barriers. So if we need different resources, hey, let's get them all in the same room and let's make the project move forward. And then this idea of this is a system that we're putting into place to do problem solving and to make processes better. And we have to recycle through that that DMAIC process. So we can't be doing DMAIC in one area and then firefighting in another. And let's pick the best answer of the day someplace else. So if we were adopting that we're going to do a Six Sigma strategy deployment in the business, we should use that and use that to make the data-driven approach to solving problems. We've reached the end of our first section here. So we've covered the objectives of Six Sigma and the Six Sigma program. We've talked about the key, variation reduction, and then we use this Greek letter sigma, which is typically used for standard deviation. So we want a small standard deviation, but we can also use it to count how many standard deviations fit between the process mean and a specification limit. And if we can count 6 of them, we're in really good shape. We talked about the implementation model, which is really On the process side, it's following the DMAIC process, DMAIC. And then the people side, we talked about the roles and responsibilities of management and the different training that you might do for the different belt levels, including yourself at the black belt level. If you're using this as part of your study for one of the standardized black belt exams, these are the body of knowledge elements that we covered here. The meanings of Six Sigma, history of Six Sigma. We went through from Motorola on to GE and beyond. Deliverables, and we'll talk more about deliverables in each section. We covered mostly the deliverables of define here, but we'll continue on that journey. The whole idea of breaking a process down to a simple math formula, that the inputs are transformed through some function to get an output, or said the other way, the outputs are some function of the inputs, and the fact that we have different voices that we need to listen to in order to start off projects at the beginning, right from that business perspective. So are we trying to help the customer, the business, the employee, or some combination thereof through execution of a project?